In this video, we'll be reverse engineering our part from its scan data, using Peel.CAD software to streamline the process, and SOLIDWORKS for the solid modelling. If you'd like to know how we got here, then check out part 1 of this video, where you can see the scan and mesh improvement workflow. Here we have our completed post-process scan opened in Peel.CAD. The first stage of the reverse engineering process is to align the scan to the origin to allow for the correct alignment of planes in SOLIDWORKS. First, we create a ground plane by selecting an area of the mesh to average. Then a front plane using the same process, ensuring this time that it is constrained such that it's perpendicular to plane 1. Our third and final alignment plane should sit through the parts plane of symmetry. To create this, we first create a cylinder inside the central hole, constrained by diameter and with its axis normal to our ground plane. Then we use the centre of this cylinder to create a new perpendicular plane using a construction method rather than mesh selection. Now that all 3 planes are in place, we can create a manual alignment. Here, we'll match plane 1 with the XY plane, making sure to flip the alignment for Z up, plane 2 with the XZ plane, and plane 3 with the YZ plane. Now we can proceed with creating more entities for reverse engineering. First, another plane on the top of the base plate, constrained parallel to the ground plane. Another plane is added to the top of the pipes using mesh selection with the similar normal selection tool this time. This is also constrained parallel to the ground plane. Next, a cross section is created offset from the base by 7.5 mm, and the maximum deviation is increased to smooth the output curve, removing any roughness generated by the mesh surface. Once created, we transfer the mesh to SOLIDWORKS, and then the entities we've created so far. Note that SOLIDWORKS display style is set to shaded without edges to improve the graphics processing speed, as the individual triangle mesh edges are not displayed here. Once the graphics body is hidden, we can see our planes and cross-section sketch. We'll create a sketch on the front plane, and the desired profile is converted onto the active sketch plane. This is extruded upwards by 15 mm and validated by showing the graphics body in shaded with edges mode. The depth looks a little too high here, so the dimension is altered directly from the graphics area. Back over to Peel.CAD, and we'll use the pipe centerline tool to capture the pathway of each of the pipes for a sweep feature. We simply select the outer face of the left-hand pipe, reduce the selection tolerance to avoid selecting any undesired areas, and increase the curve tension to pull the spline taut, removing any unwanted ripples. This is repeated on the next pipe. Since this part is symmetrical, we'll make use of the mirror tool in SOLIDWORKS. To ensure the correct diameter of pipe, we can use the circle tool to create a circle entity constrained to the top faces of the pipe. The diameter is edited up to the required 60 mm, and this is repeated on the second pipe. These new entities can now be transferred to SOLIDWORKS. Once transferred over to SOLIDWORKS, we can create our pipes. Once the graphics body is hidden, notice that the pipe centerline tool creates both a path for the sweep and also a profile. The larger circles which sit at an angle at the top of the splines are those made automatically by the pipe centerline tool. We'll hide these and use the ones we created as circle entities. Since splines often contain small curvatures and deviations that are difficult to see, it's best that we sketch over them using straight lines and arcs. We'll now sketch on the top plane and roughly trace over the spline with 3 straight lines, and then add dimensions and sketch fillets to match as closely as possible. Note that the centre of the circle at the top of the pipe has been used to fully define the start point of the sketch, and that the sketch line extends down below the base of the model. We'll see why we've done this later on. We can now create a sweep feature and tick the thin feature option, setting the direction to the outside of the sketch. Again, show the graphics body in shaded with edges mode to confirm the thickness of the pipe. This is looking good, but we forgot to make sure that this was created as a separate body. So I'll edit the feature and untick the merge result box. More on why we've done this shortly. These steps can be repeated for the second pipe, or a linear pattern could be used here since the pipes are identical. Next, the pipe bodies can be mirrored using the symmetry plane. To remove all the intersections in one feature, we can use the intersect tool. Choose all the bodies here and simply select the intersecting regions to remove them. Again, we can compare with our graphics body to make sure we're on the right track. Back to Peel.CAD, and we can turn our attention to the angled bosses on the other side. We'll create a plane on the front circular faces of the features, and then another on the rear, constraining these to be parallel. We'll use the cylinder feature next to create a solid body cylinders inside the lugs, constraining their axes normal to the plane we just made, and adjusting the diameter to 20 mm. Then repeat this for the next cylinder, again bearing in mind that we'll mirror this later on. We can now transfer these entities to SOLIDWORKS. Choose to sketch on the plane we created at the front face of the lugs and convert the entities of the cylinders. Create a boss extrude into the model and enable a thin feature with 6.5 mm wall thickness using the rear plane we created to define the extrusion depth. Sketch on the angled face, converting the inner circle and creating an extrude cut through all. Since the front edge of these bosses is looking a little rough, we'll tidy this up by converting the outer edge of the lug onto the same plane for another extruded cut, away from the model this time. Any entities which are clogging up the graphics area can be hidden as well. We can flip the model over here and repeat the process to tidy up the rear of the feature with another extruded cut. This time, mirroring features rather than bodies can be used since the bodies have been merged within these steps. Finally, we'll use the ground plane to trim away any geometry below the model. The last thing to do is create the remaining holes in the base plate. It's worth noting that these were pulled through into the cross-section we used to extrude the base earlier on, but they would have been generated as splines, and so not been perfectly circular or with the correct diameter. The simplest way to create these using the fewest features is to create a cylinder in each of the holes in Peel.CAD. The trick here is to edit the entity parameters and prescribe a length to the cylinder which extends it above and below the model. Transfer these to SOLIDWORKS one last time, and then apply a combine subtract using the new cylinder bodies. Show the graphics body once more to confirm that you've captured all the details, and now you're ready to 3D print. Here's our 3D printed version using the BigRep large format 3D printer. Thank you for watching, and check back soon for more Scan to CAD tips and tricks.